we are going to turn all the way back to 188. And we are going to do 4.5, which we skipped. And this is dilations. Or dilations. I always say it wrong. And I also spell it wrong most of the time. So there's several words you need to define, so go ahead and define those words. And so I'm going to kind of explain what we're going to be doing here. All right, hopefully we're about done since I drew my picture. So a dilation is a transformation in which figures enlarge or reduce with respect to a fixed point C. Okay, and that point is called the center dilation. And of course, we have a scale factor K. Okay. And so what we need to know is enlargement. K is going to be greater than 1. And reduction. We're going to have... well, K can't be 0 because then it doesn't exist. So K is going to be in between 0 and 1. Okay, that makes sense. If you're getting smaller, it's going to be a decimal or fraction. If you're getting bigger, it's going to be a whole number, mixed number. Okay, here's an example of a dilation. What you'd use a dilation in art. A lot of times you do this if you're trying to do a 3D drawing, where this tree, if it's close, would be this tall. If it's really far away, would be smaller. And you use this technique in art. You know, if I wanted to draw a little purple dude over here, here's a purple dude hanging out by a tree. Okay, and then I want to draw the same purple dude closer up. I could use this dilation from my point of my center dilation. Let's see, I need a sharper pencil. And I'm just going to draw this little line here. And so that exact same purple dude over here is going to be like this. Okay. So that's basically what we're doing with our dilation. Except for we're not going to draw trees or purple dudes. All right. So that's basically what we're going to do. And so what we need to do now is get out that graph type paper right here. So I want to do it in here. Well, I guess the first thing we do is not really graph. The first thing we're going to do is number 3. And you can kind of see number 3. Let's see if I can sketch it real quick. Okay. So basically what we're doing, right? Okay, and then number 3 has a lot of writing to do very, very little. But, you know, it's super exciting. And so that's P. And so it says that this whole thing is 14. And this thing is 6. So what do I do? Well, we know that this is the pre-image, the blue. And P prime is the image. And is this, are we increasing size, decreasing size? Is this a reduction or an enlargement? Hopefully you know it's a reduction. This is smaller than this, right? Okay, I probably need to give you a formula. When you're doing the scale factor for this, you're going to do the image. So the image, in this case I'll call it P prime, over the pre-image. So image over pre-image. And that should give us our scale factor. So the image is, well, 6. The pre-image is 14. So that's going to give me a scale factor of what? 3/7. And it is also, they are asking for, we're supposed to write reduction. That's it. You'll have to do a couple of those. Now we're going to move on to 15, and that's where we need our right here. So that's when we need our graph paper. So let's go ahead and do 15 here. So we're going to graph those images, and I will tell you as a warning, when you look at the problems, you have to adjust the scale of your graph. Because I don't want to make the graph too big. This can get ridiculous. Obviously, with the scale factor, we're basically talking about multiplying or dividing, right? I just ruined that. That's ugly, ugly, terrible. Well, hopefully you didn't do it. So I'm probably not going to count by ones on 15. Can anybody tell me why I'm not going to count by ones on 15? Well, and I also don't want a huge graph. I don't want to waste all the graph paper on one graph. So just looking at the first point, I'm going to graph that in blue, wherever my blue is. That first point on 15 is 6, -1. The scale factor is 3. What is the first point going to be once I do the enlargement? What am I supposed to multiply 6 by? So what's it going to be? 18. I don't really want to go all the way out to 18. So what I might want to do is count by 3s or 2s. Probably I'll just count by 3s. And so we can do that. So it does involve doing some small graphs, but it will work out. So 6, 1. I'm going to go 1, 2. So 3, 6. And so I can mark that by going like 3, 6, -3, -6. So 3, 6, this will be 6, -1. -1 is just going to be barely down, right? So that's going to be my x. -2, -4. -2 is almost here. -4 is just past here. That's going to be my y. Because z is going to be 1, 2. 1 and 2. I'll draw my little triangle. And so this one could fit on a normal graph, would have been fine, but I just don't want to make the other graph just huge. Some of them are fine. If you're doing a reduction, it's not as big of a deal. But if you're doing a enlargement, it gets to be a big deal. So we discussed z. What do I do to z? I mean, we discussed x. What do we do to x? Well, it becomes 18 negative 3. Why? Because 6 times 3 equals 18. 6 times negative 1. I'm sorry. Negative 1 times 3 is going to be negative 3. So I need to graph 18 negative 3. So I counted by threes. 3, 6, 9, 12, 15, 18, and negative 3. So that's going to be here. This is going to be my new x. Okay? So let's graph that out, and then I will reveal the answer. In our case with this particular problem, and we're not messing with it, the center of dilation is 0, 0. Okay, and it should end up looking a lot like Shaw. Okay, and I don't know if you can tell, but, well, I'd use the opposite colors on the answer, didn't I? Well, I did. That's bothersome. So the pre-image is, and the image has the prime symbols. The Z, the little... Okay. Is this piece of cake? Is this easy? Okay. We're going to do we're not going to finish today. We're going to do most of this tomorrow. So you guys can maybe get a head start here. And let me see if there's anything else I got to... So yeah, I'll shut this off and give you guys a little head start on tomorrow's work. If I can figure this out. I can't find the mouse. It's gone. There it is.